Hi, welcome to Wise Guys. This video is on the right triangle, and it's pretty much an introduction to the right triangle. So here you can see that we have two right triangles. You know you have a right triangle when you have a right angle here, and that angle is 90 degrees. And there's 180 degrees total in a triangle, so these two angles here, if we call this alpha, these two angles have got to equal 90 degrees as well. One of the things that students have problems with a lot of times is where's the opposite side and where's the adjacent side. Now if we talk about this triangle, theta is our angle, and the long side in a right angle triangle is always the hypotenuse, so it's never adjacent or opposite. So this piece here, and the hypotenuse is always the side that's across from the right angle. A lot of times when I'm working with students, I talk about the adjacent side and the opposite side by having them imagine it being a room. So if and a lot of times I'm just imagining, I say we're inside of a triangle right now, and if the hypotenuse is going diagonally across the room and one wall is part of the triangle and the other wall here is part of the triangle, if I'm standing right here in the room, the side that's adjacent to me is the wall that I can touch. And of course we're not talking about the hypotenuse because it's just the hypotenuse. So if I'm standing in this room and someone's looking down on me, the wall that I can touch is the adjacent side. The wall that I can see is the opposite side. And of course if we talk about this angle here, you can see that this side is adjacent to alpha, whereas this side is opposite alpha. All right, now here's the trig functions, and trig functions are really just ratios, and they're ratios of one side over another. So the sine of the angle is the opposite side over the hypotenuse. And it helps sometimes just to write it as sine of the angle is opposite over hypotenuse. The cos of the angle is the adjacent side over the hypotenuse. And the tan of the angle is the opposite side over the adjacent side. So usually when I'm working on trig questions, I don't like to be carrying all this information around in my head, so I just write down the information. The sine of the angle is opposite over hypotenuse. The tan of the angle is opposite over adjacent. And the cos of the angle is adjacent over hypotenuse. And when you have it in front of you, you don't have to be carrying all that information around in your head. And a great acronym for remembering this is SOHCAHTOA. So SOHCAHTOA. Sine, opposite hypotenuse. Cosine, adjacent hypotenuse. Tangent, opposite adjacent. Now if we look at this triangle here, we know the angle is right there. So the hypotenuse again is the long side, which is here, and again it's the side that's opposite the right angle. The side that's adjacent is the M, and the side that's opposite is the L. Okay, so let's walk through one of these questions. Alright, so in this question we're told that the angle is theta I should say is 18.4 degrees, so that's this angle right here. 18.4 degrees. And we're told that side C is 0.0897. So that's what we have here, 0.0897. In this question, you're being asked to solve for all parts and round to the appropriate significant figure. Here we have 3 sig figs. Here we have 3 sig figs. So our final answer should have 3 sig figs. Now this is our angle. So then A has got to be the opposite. Okay? It's across from the angle. B has got to be the adjacent side. And again, it helps just to write down your functions. So sine of the angle, opposite over hypotenuse, tan of the angle, opposite over adjacent, cos of the angle, adjacent over hypotenuse. So at this point, you have hypotenuse, you have the angle. So you could use either the sine function or the cosine function. There's no point using the tan. You have the angle, but you do not have the opposite side or the adjacent side, so you can't solve anything. You need 2 parts in order to solve it. All right, so let's just pick one. Let's start with sine. So the sine of the angle. Oh, actually, let's solve for alpha first. That's an easy thing to do. These 2 angles here add up to 90 degrees. So then alpha has to be 90 degrees minus 18.4 degrees. So we end up with 90 minus 18.4, 71.6. 71.6 degrees is alpha. All right. Now we'll pick one. We'll pick the sine. So we'll solve for the opposite side, which is A. So the sine of this angle, 18.4 degrees, equals the opposite side, which is A, over the hypotenuse, which is 0.0897. Now we want to get A by itself. Right now it's being divided by 0.0897. So on this side we'll just multiply it by that number. And if we multiply on this side by 0.0897, we have to do the same on the left. Okay, these two cancel because that equals 1. So we end up with A equals 0.0897 times the sine of 18.4 degrees. So we just put that in our calculator. 0.0897 times the sine of 18.4 equals 0.0283. So 0.0283. Okay, and that is A. Now if we look at this, we can see that this angle is really small. We know that this number is kind of 8-ish, okay? So then this side has got to be, because of the size of this angle, has got to be quite a bit smaller than this side. And so we can say, oh yeah, well it is smaller, so it's a reasonable answer, okay? Now let's solve for B, and again, let's just use the hypotenuse to solve for B. We could use Pythagoras, but since we're doing a video on trig functions, we might as well use trig functions. So let's use the hypotenuse, and we're solving for the adjacent. So adjacent, hypotenuse, we go to our trig functions, we say, oh, here they are. So we'll use the cos. So then the cos of 18.4 degrees equals b over the hypotenuse. Again, we want b by itself, so we multiply by our hypotenuse, and we multiply on this side by 0.0897. These two equal 1. So b equals 0.0897 times the cos of 18.4 degrees. 0.0897 times equals 0.0851. And that equals b. Now again, because this angle is small, this side, the adjacent side, should be similar in size to this. Smaller, because this is always the longest side, but it'll be sort of close, all right? And so that's a reasonable answer. Okay, so let's try the next one. All right, so in this case, we've been given two sides. We're told that B is 150 and that C is 345. And again, let's, I was going to write down the trig functions. Yeah, let's just do that. So the sine of the angle, opposite over hypotenuse, tan of the angle, opposite over adjacent, cos of the angle equals adjacent over hypotenuse. Okay. All right. So in this case, we've been given two sides, and when you're given two sides, we could use Pythagoras to solve for this, but we're not going to. We're going to solve for an angle. So let's solve for alpha. We have the hypotenuse, and we have the adjacent side to alpha. So then we can say that the cos of alpha equals excuse me, the adjacent side over the hypotenuse, so 150 over 345. But what we're trying to find is alpha. So then what we use is the inverse trig function. So the angle is cos, or we solve the angle by taking cos to the minus 1 of 150 divided by 345. So inverse function cos, and then bracket 150 divided by 345 bracket equals 64.2, and again your calculator needs to be in degrees, 64.2 degrees. And then if we know this, 64.2 degrees, we can also solve for theta. So theta has to be 90 degrees minus 64.2 degrees which is 25.8 degrees. All right, and then the last thing we need to solve for is A. We're going to use a trig function here. So let's use the hypotenuse, and A, this side is opposite alpha. All right, so then yeah, sine. So the sine of alpha equals A over 345. We multiply here by 345. We multiply on this side by 345. These two cancel. So A equals 345 times the sine of alpha, which is 64.2 degrees. 345 times the sine of 64.2 equals 311. So A equals 311. Okay. Now, it's a good idea just to stop and say, is that a reasonable answer? We ended up with 64.2 degrees here, smaller angle here, 25.8 degrees. Because this angle is small, then it's reasonable that this side would be similar to the length of the hypotenuse. It'd have to be smaller, but it would be close, all right? So this side being 311 is a reasonable answer. Okay. I'm just checking where my glasses went. And this video was brought to you by Wise Guys. And I hope you have a good day.